Good morning, everyone. This is a beautiful day in Washington, D.C. on this very special Earth Day and our 6th annual Earth Day Tech Summit, known as CyberEarth. With us today, we have a series of guests throughout the weekend. And again, in our 6th year, we're really excited to have a lot of good topics as our program spans air, land, sea, and space domains as cyber and cybersecurity initiatives transcend all of those pillars. Our guests this weekend will be Dr. Carlis from NOAA, Dr. Carl Hanna from NSBE and BDPA's Career Tech Talk, Lieutenant Colonel retired Jay Bullock from FEMA, Mr. Darrell Peak from Google, and we have Dr. Nicole Turner-Lee from the Brookings Institution. This morning, we're going to kick off our Earth Day weekend with Dr. Carlis from NOAA. Dr. Carlis is with us for his 6th year with us. And he's currently the deputy director at NOAA's GSL facility in Boulder, Colorado. Dr. Carlis, thank you for being with us today. How are you doing?
Oh, I'm doing great. It's great to see you, Barry.
So, Dr. Carlis, if you don't mind, share with us the exciting research and development opportunities that you may have. Also, talk about any new exciting evolutions that have occurred since we last spoke last year. And hurricane season is not too far away. So, if you can shed some light on how NOAA works with everyone, including the Weather Channel, to make sure that we are prepared and we understand what may be facing us in 2022.
Absolutely. Yeah, speaking on that hurricane season, we should have our hurricane outlook for starting in June coming out within the next month or so. It usually comes out at least a month or two, at least a month before hurricane season actually starts, where we'll actually talk about really what we're expecting for hurricane season this year. I want to talk about monitoring the pulse of the planet. Perry talked about land, sea, atmosphere, and space. You know, you think about NOAA, the National Oceanic and Atmospheric Administration, and our mission really spans all of those specific areas that BDPA is really focused on. And so just in terms of an introduction, again, my name is Carlis. I'm the deputy director. I'm also a meteorologist, trained meteorologist at the Global Systems Laboratory in Boulder, Colorado. And if you notice this particular picture, you'll see the sun and coronal mass ejections compared to the Earth. You see how small the Earth is compared to the sun in this particular picture. So welcome to Earth Day. I'm excited to be here with BDPA, and I'm really looking forward to having this conversation today. So just to start off, I want to talk a little bit about myself. I was born and raised in Tulsa, Oklahoma. This is me and my 2 siblings at the bottom left. I have more siblings than this, but this is a pretty old picture. And so born in Tulsa, Oklahoma, took the journey to Washington, D.C. When I was introduced to Howard University at the age of 16. So I moved from Tulsa to D.C., cried all the way along because I knew I was going to miss my mom. But it was something that I really had to do. It was something that I felt in my heart that was the best place for me. And after 3 degrees from Howard University, I can absolutely say, yes, that was the best decision for me. And this particular picture here is of our Vice President, Kamala Harris, of course, a Howard University alum as well. And so just wanted to give her a shout out. And during that time at Howard, I got introduced to NOAA and I applied for a position at NOAA. And NOAA moved me to Honolulu, Hawaii, where I stayed and I worked for the National Weather Service for multiple years, building high resolution weather prediction models. And after Hawaii, I moved back to Washington, D.C., where I became a research meteorologist and worked at the Environmental Modeling Center. And during my time in Washington, D.C., I've held multiple positions in Washington, D.C., both as a meteorologist, as a policy advisor to NOAA leadership, as a program manager, managing and allocating funds to research scientists out in the field, doing research, doing cutting edge research at that. And then at some point in 2020, I was thinking about kind of career next steps. I had, over 18 years in NOAA at that particular time. And I decided that I wanted to take that next step in terms of leadership. And I applied for a position here in Boulder, Colorado, where I work as the deputy director of the Global Systems Laboratory, where we have over 180 meteorologists, engineers, just physical scientists, chemists. We have all different types of field, as well as administrative staff to help support the science that we do. And it's a fantastic organization. I've had a fantastic time here in Boulder. As you can see in this particular picture, Boulder is a very beautiful and picturesque place. So I'm happy to be here. So let's transition to NOAA. What's the mission of NOAA? We talk about science, service, and stewardship being kind of our mantra at this particular agency. But when you kind of break it down into its three parts, it's really about understanding and predicting changes in climate, weather, oceans, and coasts. We want to take the information, the things that we understand, and share that information with the public. And so we do that through collection of data, going out and taking satellite measurements. We have ships at NOAA. We have airplanes at NOAA. We hire divers that go out and study coral reefs and different species. So conservation and management of the coastal and marine ecosystem and its resources, whether that be turtles, fish, or other animals in the ocean. We do it all at NOAA, and so again, we span that land, sea, space continuum within our agency. I talked a little bit about data in that last slide, and when you think about data at NOAA, you look at this graphic, it's showing basically on the x-axis is the fiscal year. And then on the y-axis is the volume of data in terms of NOAA's data archive in petabytes. So it goes from 0 all the way to 160. And then you have these different types of data that NOAA collects, whether that be satellite, whether that be the NEXRAD, 88D radar data that is collected. You'll see that type of information on your television screen during the weather forecast. We also have model data, and I talked a little bit about that a second ago. Numerical weather prediction model data that we produce to do forecast and projections of what that future weather will be like. We collect ocean data sets. We also have geophysical data where we launch balloons, and I'll talk a little bit more about that in a minute. And then the atmospheric in situ data. So these are the different types of data that we collect. And as you can see, the amount of growth in NOAA's data archive. You see here in 2020, projected to be about 80 petabytes. You compare that to what the projection is going to be in 2030. It's close to a little bit over 150 petabytes. So the growth of NOAA data and the importance of NOAA data in terms of you as the public being able to make decisions using this information, whether that be from a app on your cell phone, or you are a citizen science and you're out collecting data and sending that data back to NOAA so that we can archive it in this particular archive. So what's some actual examples? What does this look like when it comes to observations around the country? You see here at the top left is data that we collect via buoys. You'll see in this particular map projection, the United States up to the in pink to the top right. And then you see all of these dots kind of all around the United States and really along the equator. We have buoys all along the equator to collect information, to study climate change, and to collect all of the data that we really need for our numerical weather prediction models. If you go into the bottom left, you'll see that the National Weather Service, which is a part of NOAA, collects data all over the continental United States. We have different sensors and stations at almost at every single airport across the United States. And then when you go to the top right, we have 122 National Weather Service offices from the continental United States all the way out to Guam, Alaska, Hawaii, Puerto Rico. And in these locations, we have what we call the NEXRAD system, where we actually collect weather radar data, which is that bottom right picture that you ever drive around and you see that big white ball. That's the NEXRAD system. And we also collect in situ observations using radio signs as well. Now, what are some other types of data that NOAA collects? Let's go to space. We measure the pulse of the planet through our operational satellites. We have a minimum of probably around 6 to 7 satellites, both global satellites that basically monitor a specific area of the planet. And we also have what we call the polar orbiting satellites as well. And we can't do this alone. We have to have partners. So when you think about the partnerships for collecting observations across the globe, you look at this particular image, you see countries like Japan, South Korea, India, China, France. They're all part of an integrated observing system where we are measuring, all different aspects of our planet from temperature to precipitation to humidity, all of those types of measurements, winds as well. So we can't do this alone. I think our partners are really important, and also the public is really important. You can play a role in this too from a citizen science perspective. Now, what does this look like when you actually take the data and display it? So this particular example is of just a simple satellite image of the visible satellite image over the continental United States. You see the Atlantic Ocean to the right, and you see the Pacific Ocean to the left over here, and you can see this white cloud structure that's forming over Oklahoma, Arkansas, and pretty much over the Midwest to the Southeast areas as well. So we use this satellite data and display it in multiple different ways. And now that satellite data is actually used as input to our numerical weather prediction models. So this particular data set here is actually a prediction. It's not satellite data, but it is a model. It is, algorithms run through a supercomputer to create a simulation. You'll see kind of in the center here of this particular image, and this is a movie basically, you'll see hurricanes being formed. And this is all mathematics run on supercomputers to create an image that looks like a real-time satellite image. So you'll see a couple of hurricanes forming in this particular movie loop here. You see the United States to the right. So we do this on a global scale, and it takes all of the data that I talked about from the partners, the integrated observing system, to create images such as this, because the data that we collect and how we monitor the planet is so important to being able to actually do projections and predictions for what the future state of the atmosphere will look like. And now let's take a look at, smoke. Wildfires has been one of the biggest issues that we've been dealing with in the United States, probably for the last 10 plus years. You see fires coming from California. You see there to the left on the west coast of the United States. This is basically a prediction of smoke, the amount of smoke in the air. You can see that this smoke goes to the north up over Canada, and then it actually comes down to the south and comes back towards Washington, D.C., and goes over the Twin Cities. So it's not just, the smoke from California, from wildfires in Canada can impact areas on the East Coast of the United States. So these are things that we should be thinking about and how we monitor the pulse of the planet from our ability to collect information and understand where, the air quality that's impacting our country. Now let's take a look at this from a global simulation. So this is a forecast of smoke, integrated smoke over the continental United States. As you can see, you can see it over the United States, but then look to the west over Asia and over Russia. You'll see some smoke coming out of that particular area that's now actually going to start to move towards Canada and into the United States. So it's not just a regional issue. The planet is connected. And this is from a August 2021 fire that happened out over in Russia and in the Asian portions of the globe. Now, this is another image. We are really changing the way that we monitor severe hazards, such as severe thunderstorms, such as tornadoes, things like winter precipitation. You see these yellow and red hatched areas. You see this is a radar image of a severe thunderstorm. And you'll see in this particular image that the hatched area, which is a watch, and the red is the actual warning. You'll see that it actually follows the storm. It moves with the storm. So we call this this is a threat in motion. And if you are in this particular kind of red area, the threat of the severe thunderstorm is different if you are in that red area compared to, say, the yellowish area, right? And so we are really trying to change the way we communicate hazardous weather information to the public. So I don't know if many of you have cell phones. You probably have received some type of watch or warning on that particular cell phone. And it's because you may be, in terms of where you're located on the globe, you may be in one of those red areas or in one of those yellow areas. And so we have the ability to send a direct message to your cell phones so that you get that information and know that there's a potential for you to be impacted by a severe thunderstorm or tornado. So when you think about some of the work that NOAA is doing, this particular movie loop that is all about really focusing on our ability to forecast these billion-dollar weather disasters. So you'll see the hurricanes, you'll see drought, you'll see fires in this particular image. And you'll also see tornado outbreaks. And so when you think about, in 2020, the number of billion-dollar disasters related to weather, related to us being impacted by, the weather and drought and fires, all of those types of hazards, it's really damaging. And I'm telling you, it's really important that we continue to invest in these areas so that we can understand and know how to look at and project what's going to be happening on our beautiful planet. And so as I kind of start to wrap up this particular session, I want to talk to you a little bit about one of NOAA's education programs and highlight the Educational Partnership Program. This is how I came into NOAA, through the Educational Partnership Program. If you just do a Google search for NOAA education, you'll be able to go to their website. And we give out graduate fellowships. We give out grants to K-12 and organizations. And of course, we give out undergraduate scholarships as well. That's how I got started. And you know, those scholarships are worth a pretty penny. So it's somewhere over $40,000 to support your education at the junior and senior level. So I would highly recommend those of you that are interested in science, in really kind of NOAA mission related fields, whether it be oceanography or meteorology or marine biology. I encourage you to check out those websites and apply for those programs, because they can absolutely help to change your life, just like they did mine. And so this final slide really is about, you know, my keys for success. And that's I think the most important thing to me was that I had a great support system, whether that be my parents, my friends, my wife. And so you'll see in this picture, it was my wedding day. We got a chance to hang out with Bill Clinton on my wedding day. So that was a pretty cool and awesome opportunity. And speaking of opportunities, I talked about the NOAA education program that I got into. You know, taking advantage of those opportunities and seeking those opportunities. This was the day I joined NOAA with a cohort of other students that were part of the EPP Educational Partnership Program. One of the days that changed my life, absolutely. And then inspiration. You know, once you take that opportunity, what's inspiring you to actually, you know, do, you know, great things for this country, for this you know, world that we live in? You know, who are those people, whether that be your parents, whether that be mentors? I had a ton of mentors that inspired me to pursue my career and be in STEM, be a scientist, all of those things. And so these are just a few of those people. And then none of this matters. You can have support, opportunity, inspiration. Unless you take action and take control of your career, then it won't even matter. So taking control and taking action over where you go, who you hang around, all of the things, the science that you do, what you're really fully interested in. You know, you got to take control over that part of your life so that you can progress and succeed. And so I just want to encourage you guys to really think through some of these keys for success, because for me, these are the things that have led to me being a deputy director and a scientist within a federal agency called NOAA. So I thank you for this opportunity to share my story and to share really how NOAA monitors the pulse of the planet. So I'll stop there. Thank you, Perry, for this opportunity.
And we'll be right back after these messages.
Every year, we come together here, marvel at the view, and strengthen our resolve to preserve it. This year, we arrive again. Our ambitions are bigger because our obligations are too large to measure, and our opportunities too substantial to squander. At Microsoft, we bring unparalleled sustainability commitments to over 33 million square feet of real estate around the world, creating modern workplaces where nature is the building block of our designs. Because thinking sustainably, building sustainably, living sustainably, and working sustainably is in our nature. So this year, let's commit ourselves to making Earth Day every day.
Yes, sir. Thank you very much. So one question I had was, Am I too old to be an intern? Great presentation.
Oh, be an intern.
Yes, sir. Great presentation. But so we do have a few questions as usual. And as you know, every time we have these seminars and sessions, these questions are geared toward parents and teachers and students. But on the supercomputing modeling that you mentioned, used to create images and predictions and projections that you mentioned, especially showing the smoke and even potential inclement weather. What if I'm in middle school, high school, what type of courses would help me prepare myself for careers at NOAA?
I think from a high school to middle school perspective is really focusing in on your science and math.
Okay.
No matter what type of science and math it is, continuing to practice math and to enjoy science. I remember one of my mentors would tell me about him being in when he was in high school, he would do chemistry experiments in his off time, getting some of those, scientific and engineering type of games, that companies sell to get kids interested in STEM. Those are things that are really, really important. And I can't stress the amount of math that's really important to actually being able to do visualizations, to be able to do numerical weather prediction, because all it is really math. So when you think about kind of my path, I always felt that I was good at science and math when I was in middle school and in high school. And so I did not know that I wanted to be a meteorologist. Absolutely not. I knew I wanted to be a scientist. I thought I was going to be a medical doctor and try to be like one of my mentors. But science and math was really the key for me, and that basically led me to a career at NOAA, being a meteorologist.
And just like we discussed last time in our last series, I was always excited about maps. And I know coincidentally, next week, I know GeoInt is headed out in your neck of the woods in Aurora, Colorado. Mm-hmm. But related to that, when you mentioned the projections earlier, these will change over time, because as we add new platforms and new systems, you're going to be collecting more data. So if you can just share some light as to, on the projections you gave out to FY30, do you envision, once we have new sensors coming online, new satellites coming online, what impact will that have on your projections and predictions?
Yeah, those projections and predictions are, again, just a projection and a prediction. Right. We don't know exactly what the new sensors in terms of kind of data formats, data volume that some of those new sensors will actually be. And so when we pull together these projections, we're estimating similar to the way that we kind of forecast the weather. It's a educated guess, right? But there's tools that we can use and knowledge that we can use to create these predictions and projections of the amount of data that we have. And it's important that, when we think about the integrated observing systems, it's not just NOAA, it's NASA, it's Department of Energy, it's other organizations, USDA, especially when it comes to some of the smoke forecasts that we're going to be using, in terms of the Forestry Service. So it's really all of us together understanding how to produce and collect the right information so that we are able to accurately predict what's going to happen on this planet.
And that also takes us into one of our, it's not a formal tagline that people always ask, what does BDPA stand for? And as you just alluded to, big data and predictive analytics. That's one of our first responses, especially for young men and women that are in middle school and high school. And along those lines, we're looking at artificial intelligence, machine learning, and you touched on the high performance computing, or being able to get more accurate forecasts and producing information faster. Where do you see young men and women who are interested in data science, graphic artists, videographers? What role would they have in organizations such as NOAA?
Oh man, a very important one. You see, I showed a lot of
Mhm.
images, a lot of visualizations, because that's one of the easier ways to communicate the impact of the science. It takes software engineers, it takes data scientists, it takes videographers going out and doing stories on, you know, basically going out and going to, say, like a satellite launch and seeing the NOAA and NASA scientists that built the satellite, that built the instruments on the satellites, and can tell the stories behind uh, those satellite launches. And so we all have to come together as kind of, just a human, in a human dimension, so that we can actually be able to tell the story and the impact of why we do what we do. Why do we actually go out and, launch balloons that have temperature, wind, humidity sensors on it twice a day? How does that impact someone sitting in their home that may be going to work on each and everyday basis? All of those things matter. The little things matter in terms of the data that we collect and how we actually put that information out there to the public.
Yeah, that's very exciting. And in fact, some of those areas may or may not require a college degree. What are you hearing within your industry? And some of those areas, I know you mentioned science and math earlier, but the storytelling, aggregate data collection,
Yeah.
do you see a relaxing or enhancement of any particular education after high school?
I think in terms of kind of the federal workforce, we do have a pretty highly educated federal workforce. But when you think about, our ability to go out on ships and collect, um, to basically fix some of the data sets that are out there, that doesn't necessarily require a degree to go out and repair some of our data sets that are out there, some of our information that we're collecting out there. So it there is a highly skilled, highly trained workforce within federal agencies, but there are opportunities for those that are at the associate's degree or just high school education level. And so I would hope that, in the future, as we continue to, expand our ability to collect some of this information, that we would consider folks from community colleges, folks straight out of high school, to be able to do some of this work for sure.
And also earlier you mentioned on some of the scholarships, similar to other agencies, do your scholarships require any commitment of time upon graduation as a
Well,
payback, almost like a payback tour?
yeah, the one that I was in did require a return on investment in terms of investing my time back into the agency.
Mhm.
But if you're at the undergraduate level, it does not require that. I think only at the graduate level does some programs within the federal government actually require you to actually work for the government for a certain period of time, for depending on the way that they support you in terms of financially.
And then finally, our final question for some of our arts and science students, policy, some of the opportunities in policy. This is our final question. And since this is Washington, D.C., I would be remiss if I didn't talk about Congress. So
Yeah.
some of the challenges and opportunities that exist for young men and women that are interested in legislative affairs, government relations, or just helping NOAA with policy, both external and internal. What does the future look like for them? What's a typical career path for them could be?
I mean, it's extremely important. I think, there are people that can go the scientific route to get to policy, which I did. I focused on being a scientist, being a research meteorologist for many, many years, developing my expertise in terms of my knowledge and ability to do research, and then really translated that over into a policy position where I was advising senior leaders on weather research and weather forecasting. And so it goes both ways. You know, you can also take the political science route, or, you know, go into law and come into policy. And we, you know, NOAA has lawyers, hundreds of them, because we get sued regularly about our fisheries policies. So those are things that you can go the scientific route, or you can go kind of the policy route and be able to provide information to and advice to Congress, to senior leaders. And, you know, when I think about kind of science policy, you know, you look at Congress, there's not very many scientists that are congressmen and women. It's not too many scientists that are senators. And we need more of more scientists to become congressmen and women and senators. And so I would even, it's probably less than 1% of the number of people that are in Congress that have a scientific degree. And so being that there's so few, we have to depend on the scientists that are coming through the ranks to want to be in science policy and reviewing some of the legislation that's coming up and out of Congress. And so we have a very, very important role in providing advice and making sure that the policies that are coming out of Congress have a scientific base, and that it's accurate in terms of the science that we're doing.
Yes, sir. Very, very important. Even establishing our widening our network with the staffers in many of those committees. So, Dr. Carlis, thank you so much. I appreciate your time this weekend. Again, it's a beautiful day here in Washington, D.C. For CyberEarth22 and Earth Day. So, sir, you and your family and your team at NOAA, please have a very happy Earth Day weekend. And thank you so much.
Yes, thank you very much. Happy Earth Day, everybody.